Hey everyone, and welcome to the last lab for Chem 102, having to do with redox reactions. So what you're going to be doing in this lab is electrolysis. You're actually going to be breaking water up into hydrogen and oxygen, and also into hydrogen ions and hydroxide ions. Now those two half reactions, the reduction reaction and oxidation reaction, are in the lab, and you'll have to identify which is which. But this is a fun one because it involves some color changes. So what you're going to need from your kit, you're going to need this bag that contains a battery and some sodium acetate and a petri dish and battery leads. You're going to need from the dye kit, you're going to need the bromothymol blue dye. You're going to need a pipette or something to squirt the dye into the solution. And you're going to need your safety goggles, of course, safety first. And let's see, so you're also, turns out, going to need some vinegar, just a little bit. I have some in this little cup here. In fact, all I had was white wine vinegar, so that's what I used. And you'll see why we're going to need that in a moment. Okay, so I'm going to angle this down, and we're going to set this up. So the first thing you need is your petri dish. And we're just going to toss the lid aside. It's also helpful to have a white piece of paper to sit this on. It'll be much easier to see. So I have a helper who's here with me today, who's going to introduce herself.
Hi.
And that's Lena. And she's going to be making some observations for us. So she's going to tell us what she sees when we, she's going to be our color judge, okay? So first you're going to need to take the sodium acetate. In the procedure it says to use 40 milliliters, which is fine. You can measure it out. You really just need enough in here to cover the bottom. You know, maybe make it sort of half full, okay? And then we're going to need to add some bromothymol blue. We want to get a nice rich color, so I think 1.5 to 2 milliliters, and there's milliliter markings on here, but if you can't measure it out, just try to get it to a nice kind of dark color because we want to be able to see the color change. So this is 1 milliliter, and I'm just mixing it up. Now, we have a problem here, and the problem is that this bromothymol blue currently is blue. Now, bromothymol blue is a pH indicator. It's blue in basic solutions, it's yellow in acidic solutions, and it's green in neutral solutions. So I have a nice deep coloring here, but I don't want it to be blue. I need it to be green, and I should have pH balanced the sodium acetate solution before sending it to you, but I did not. So it's blue right now, which means that it's a little bit too basic. So I need to make it neutral. I want it to be neutral, so I'm going to add a little bit of acid. This is kind of a trial and error thing, so I'm just going to get like a drop of vinegar, add it, maybe 2 drops to start, and I'm going to stir it up. And Lena here is going to be my color judge. So you can see it's kind of yellow, and we want it to be, what did we say? Like a dark teal?
Yeah.
So
It's usually
I honestly think that might have been enough right there. What do you think? Or is it too blue still?
No, that's actually a really good teal.
Yeah, I think this is a really good teal. I'm just going to keep mixing it because sometimes the color adjusts. Does it look like it's getting bluer?
No.
It looks like a good teal color?
Yes.
Okay, so this is like a dark green. It's not too blue. And that's because when we do this experiment, we're going to see some blue and we're going to see some yellow, and we want to be able to distinguish those two. I don't know, I feel like it looks a little bit blue. Should we do just a little bit more acid? Okay, just like a tiny little drop. And
That does
just gonna
not
mix
look
it.
tiny.
I know it did look bigger when I put it in there, but I think it's okay. All right, so we got a nice good green.
Yeah.
Dark green there. All right, now we're going to proceed with the experiment. So, thank you very much for your help. I'll call you back when it's time to do the color change part. So now we're going to take out the battery leads, the battery. Open that up and take it out. And there's also some pencil lead in here. All right, so the pencil lead, this is carbon, graphite, and this is going to be our electrodes. And so we're going to need to attach a piece of carbon to each of these ends of our wire. All right, so I've already snipped mine, but when you get yours, when you pull yours out, I don't know if you can see this focused very well, but the ends of the wire that are exposed are usually very small. So it helps to get a pair of scissors and very carefully just cut the plastic, cut away some of this plastic coating. Let's see if I can do this on camera. I'm just trying to make little tiny snips in the plastic without cutting the wire. And if you have wire cutters, or you can do that, which I do actually have. My husband pointed out, but I'm going to do it with scissors anyway. This is probably what you guys will be using. So I'm just making little snips here, and until that plastic is loose enough to be able to just slide it on off. So I have separated it, and I'm going to slide it off. Ow! May have poked myself with the wire. And I broke the wire. And that's because I've already used this one. So we're going to trim it a little bit more. So the reason that we need to expose a little bit more wire, because you need to have enough to really wrap around that piece of lead so that it holds on securely to the lead. There we go. Okay, so now I've got a good bit of wire exposed on both sides. I'm going to take 2 pieces of lead, of pencil lead, and ta-da, move my acid away here. And I'm going to wrap this wire. You see what I'm doing? That out of the way temporarily. I'm going to wrap the wire around one end of the piece of lead. And I'm doing this all before I attach this battery, the leads, to the battery itself. And then I'm going to take this the red wire, and wrap it very carefully. So no, remember, pencil lead, graphite is very fragile, so you want to do this carefully and try not to break your lead. Your graphite, I should say. Stop calling it lead. It's not lead, it's carbon. So now we have these 2 wrapped on here. I did not break them. If you do break them, you have extra pieces. So now we can attach the cap to the battery. All right, and notice that I'm working to keep these electrodes away from each other, keep them apart. You can hear the animals playing tag in the background. All right, so you do not want to touch these together because they will heat up. And you can, if you want, just like for fun to see what happens, but don't leave them sitting there able to touch, because this is what happens. They get very hot. Why are they not? They're sizzling and smoking. I don't know if you can see it, but they're very hot and they're smoking, and you can kind of smell it. Okay, so don't do that. It will actually start a fire if you leave it on paper. So kind of fun to play around and see, but carefully. Okay, so I'm going to need my assistant back here. So now it's time to actually electrolyze and break water. And when we do that, we are going to produce hydrogen ions, which make the solution acidic, and hydroxide ions, which make the solution basic. And since this solution has a pH indicator in it, we're going to see those color changes. It's also going to produce hydrogen gas and oxygen gas, which we're going to see in the form of bubbles. So what you're going to do is just stick your electrodes into the solution. And what you should see at each, you'll start seeing bubbles being produced, and you'll start seeing a color change. One of the colors is a little bit easier to see than the other, so that's why I say hold it in here for a good couple of minutes. So Lena, what colors are you seeing, or what observations do you see?
So I see blue, and I see vaguely, just real vaguely, a yellow.
And what else do you see
I see
besides colors?
I see that the yellow has bigger bubbles than the blue. And I see that there's acid in each of these little wire things, and each acid is like making these colors and all the bubbles.
Well, that was a good try.
Yeah.
Not quite right, so hopefully my students won't write your answers for their answers.
Yeah, I am just 8, so.
But
I'm
that
just
is
8.
the experiment. It's a pretty one, isn't it?
Yeah.
Now I'm going to take this out. I'm going to remove the cap from the battery. I don't want to leave it attached. I don't want these electrodes to start any fires.
Nope.
And take a picture and then swirl it together, see what happens. It's like a tie-dye. And that's the end of this video. Bye now.
Bye.